Manufacturing is more than simply making things. To produce products in quantity at high quality with low cost requires the synchronized application of capital, labor, and equipment in a sort of industrial ballet, where the competing requirements of time, cost, and speed are calculated and recalculated on a real-time basis. To achieve success, manufacturing processes have to be planned carefully, and to stay successful, manufacturers must aggregate, analyze, and act on multiple data sets generated by manufacturing processes and today by the products themselves. Knowing what to do with that data and how to analyze it to generate actionable insight requires tools as complex as the production equipment itself. Simulation to model what-if scenarios is now standard, and artificial intelligence is expected to make rapid inroads in manufacturing. But today the key is the digital twin. But that twin is not the end goal, it's the starting point. And joining me to discuss where manufacturers need to go once they leave that starting line is Michael Buckley, 3D ExperienceWorks manufacturing expert at Dassault Systèmes. Michael has 20 years of manufacturing experience throughout the Midwest. And Mike, welcome to the show.
Hey, thanks for having me on today.
Mike, there's so much to talk about. I mean, it's just the subject matter is so important. It is so broad. But in my introduction, I talked a little bit about how we tend to sort of fall into some of these the names of some of the hot button issues, and we talk about a digital transformation, the digital twin, for example, advanced simulation. Is there one starting point? Is there one place where people in this industry can sort of grab a concept and say, all right, that's where we begin this process?
That's an interesting question. And unfortunately, there's a lot of marketing out there trying to sell a lot of things, right? And so we add confusion to it. But I think for most people, and what we've seen with our customers is, first, a company knows they have to know they want to improve. And then the second thing is they have to look at where the best bang for their buck is. Maybe it's in automation of machining. Maybe it's in adding robots. Maybe it's in improving their factory flow that they currently have without adding any new equipment. So it really comes down to, us working with them or with the company internalizing, like, okay, let's be real with ourselves. What is the biggest bang for the buck that we could have the most impact on for the least amount of investment today?
Yeah. Now that's sort of that definition phase. It's so important, and yet very rarely do people really think that through when you want to dive in, because the technology is so sexy and the potential benefits appear so great. You want to just sort of like throw money and dive into the problem head first. But I'm thinking of the days when CNC machine tools evolved. Basically, is that the machine did what human machinists did. So it's fairly easy to conceptualize why the 5-axis machine can fly cut that block of tool steel faster than a person can. But we're talking about the processes now where it's not that obvious, where you automate something or you integrate a design and manufacturing process, and you push a button and the thing goes. But is it that easy to measure exactly what your expectation should be?
There's a couple things that are at play, right? When you think about the change from manual machining to CNC on like a mass scale, right? CNC's been around forever. But when you think about everybody adopting it, and most people today, when they have a startup business, they're like, I'm going to go get a CNC machine. Where 40 years ago, it'd be like, I'm going to go get a Bridgeport, right? Yeah. Or an email. I think that the thing that comes into play with being honest with yourself and looking at that is you have to look at the generational differences between 40 years ago and today. Most of the companies today started 10, 20, 30, 40 years ago, and they were young in their careers, right? So everything was new, and they were adopting technology and whatever it's going to be at that pace. When you look at a lot of business owners today, they're sort of looking on that back nine, if you will, where, okay, I'm going to retire in 10 or 15 years, or I'm going to sell this company to somebody else, maybe internal teams that are going to buy it. And the challenge that gets in the way is often a little bit of pride. I spent a long time building this company to get where I want to get. And then it's like when we have that honest conversation about what's the next 20 or 30 years look like, most companies are like, well, yeah, but I spent 20 years building this, so that can't be where I need to make the change. I got to make the change somewhere else, right? And I think when you look at simulation, to answer your question, can it be as easy as pushing some buttons and doing that? Yeah, it absolutely can be to that point, but it all starts with, okay, where do we actually want to go and how do we want to redefine ourselves for the future? And that's going to determine the roadmap for how we push that button to get that result. And like I said, it could just be, I live in an area with a declining population, so I have to put in automation. Putting in automation doesn't mean I just go buy a robot and throw it on the floor and I'm happy with it. It means that, okay, what is the best automation for me to be successful based upon the next 10 or 20 years? And I think understanding that allows me then to put in the correct simulation or data collection tools to be able to determine what's the best bang for my buck.
Mike, do manufacturers these days, is it, do they work from the goal backwards? Or what's the time I remember it was a matter of, we need a 5% improvement in throughput, machining this casting essentially down there. So you went shopping for a solution that will deliver that, say, that percentage target improvement or that cycle time reduction, for example, or ultimately just a matter of cost. And someone says, we've got to pull 4 points out of the cost, the production cost of this product. How we do it, I don't care. Just, bring a consultant in basically and tell me what to do. Does it still work that way, or is it a little more sophisticated now?
It depends upon the type of shop, right? Obviously, at the end of the day, we're all concerned about making more money, and that drives a lot of things. I think for some shops, it's about I need to make my cycle times faster, right? I need to get more unattended hours. Or in some instances today where you're a small manufacturer supplying to big companies, one of the things that's changed in the last 4 years is the big companies got burnt by supply chain issues, right? They had hundreds and thousands of millions of dollars of equipment sitting there that couldn't be shipped because of things like chips, right? So bigger companies are now putting pressure on the smaller companies to be more transparent with what's their forecast look like, what's their capacity, are they going to be able to meet the demand over the next 6 to 9 months? And I think a lot of those outside metrics that they have to be able to supply now is forcing that scenario where we look at, okay, how fast can I go? How much throughput can I have? Do I need to have more material storage? What does that flow look like? I think there's a lot more pressure from the bigger companies now pushing on the small ones to create that digital content to understand really where they're at. Where 40 years ago, it was like, yeah, I got a gut feeling I can make that in 10 minutes and it's okay. We got some room and I can just throw more people at it. Today, it doesn't exist that way.
Yeah, I understand. I see it myself touring manufacturing plants here at engineering.com. It's a question that used to come up frequently. I'm sure it still comes up today the same way, is that it's the cost benefit analysis of, do I automate extensively? Where do I put the automation? Essentially, now you described a scenario I'm seeing very commonly where it's not even a question of where do I put the automation. I just can't get the people. I need qualified people. They are not available, full stop. So I have no choice but to look for an automated solution. Or conversely, some solution that lets me take my high-skilled people and train them up into a higher value role as another way to control cost on there. So is there an HR component to this? Is there an element where we've got to digitize our system just so we can better use the people we have?
Yeah, and a lot of times, if you look at news reports today, everybody wants to focus on the negative, right? And I think that a lot of times it's like, oh, we don't have enough people, we're sunk, we're out of control, we can't do X, Y, Z, A, B, C. And the reality is it's a little bit of a blessing, because in the past we would just hire people, we'd bring them in, they do a job, and then we don't need them anymore. We would just let them go and they could do whatever, because oftentimes they weren't our high skilled people, they were just bodies to fill a process. With the people not wanting to do those things anymore because it's a risk for them personally to come in and work for a month and then get laid off, the switch to automation now allows a company to be more self-sufficient, but they can go after and they can actually hire or train skilled users that will stick around longer, and they get more capacity out of each input. Because an employee can be an input just like a CNC machine or a robot, right? I pay X amount of dollars, I get X amount out. And the more I create a skilled person, the more output I get for the input, right? So I can actually increase my capacity internally by having better educated people or bringing people in and mentoring them like we used to do back in the old days, right? Internships, bring them back in. And we have a lot better run than just the revolving HR door that we've had in the past, where I got to get this out. I hire 50 people knowing I'm going to lay them off in 6 months. And so I think we're going to see a transition to where the people we have are better. But I also think we're going to create more stability in manufacturing, because we're going to be able to be more consistent, because everybody is going to level up, if you will, using gamer terms, right?
Yeah. Yeah, it's interesting. I come from the automotive world, and design for manufacturability was of course always a major issue, because production volumes are huge. But we also had some time to do it, because you'd be making the same part or the same assembly over a platform life that might be 4 or 5 years. So you've got a little time to kind of tweak your processes and shave a few costs and keep your quality up. I'm seeing certainly a lot more shops who really work in that classic high mix, low volume environment where things are just changing. I mean, forget week by week, day by day, basically. Is that pressure to basically get up to a profitable manufacturing run faster? Is that an element you think in driving this push to digitization?
Yeah, 100%. I think mass customization, or the Amazon effect, right? If you will, everybody can get whatever parts they want, but then it's like, do you want a red, blue, green, yellow versus, the Model Ts where you get a black, right? I think that mass customization and the ability to connect directly with a consumer has changed how we look at manufacturing. We have to be able to create small runs, but create them in a consistent fashion to where it's repeatable no matter what goes in there, right? How do I do advanced fixturing? How do I create setups and control? How do I digitize and validate my process before I ever turn on the spindle or turn on the robot to do its process? And I think when you look at manufacturing side, we can't, ignore the people like what I went to school for, manufacturing engineers, because a lot of that falls on their plate, right? I can design any widget in the world, but how can I fixture and make those components in a way where it doesn't matter if it's red, green, blue, or black, it's all going to be processed the same out the back end. I think that's the key to being able to be flexible, but also shorten the ebbs and flows that happen in manufacturing. Because if I can do a million different little parts as efficient as I could do 1 million part run, I'm going to have better capital to work with long term because I'm not relying on just whether the automotive industry is up or down this month.
Yeah, interesting point. Now, you mentioned fixtures, and I'm glad you went that direction. I think jigs and fixtures get nothing like enough love in manufacturing. And you can make or break the profitability in a job by how you fixture something, how you develop fixtures. Back in the day, of course, jigs and fixtures, they were sort of almost like an overhead cost. They weren't usually directly costed into the price of the product. And you could get a situation where the customer may ask for design change. And the design change from the engineering office standpoint looks relatively minor, but has knock-on effects that could require a lot of changes on the assembly line. And some of those costs could kind of sort of disappear into the ether. And then you wonder why you're upside down on a part or your profitability target, wasn't where it was on there. Today, we've got the technology where we can intelligently design jigs and fixtures, but we can track them and catalog them, basically. Is there a ripple effect up to let us more intelligently cost jobs now with this new digital technology?
Yeah, I think absolutely. And I think it's been part of a 25 plus year transition, right? You think about when we used to do fixtures and tooling, we'd do them in 2D, and oftentimes, we'd go take it to the fixture shop and then they would take the 2D, but they would tweak it, adjust it however they want to do it, right? And we have an accurate representation, but not really accurate, if you will, because somebody may have made that change. I think, over the last 25 years, where most people on the planet now design in 3D, they can do that extra validation verification. You have kids in college that are doing fixture design in 3D. I think the next evolution of that to be able to figure out the costing and the processing is because I designed that fixture in 3D, I can now simulate my robot program or simulate my tool paths using that same 3D geometry, where traditionally it's always been a disconnect, right? We create a rough whatever, the shop goes and makes it, it's this black hole, and then we go spend a whole bunch of time in the shop trying to figure out all those little details because of variation. Where today we have a seamless flow of data from the part to the fixturing to the programming and calculation. And I think that really allows us to control our costs because now we can pull old fixtures, bring them in and say, okay, well, I can use 98% of this fixture again. I just got to make 2 little parts, bolt them into this universal fixture, and now I have a brand new component. And in the past, that would be a really challenging thing for us to do and take an enormous amount of time with the machine shut down, where today we can just plug it in and go, reducing our downtime, keeping our uptime as good as possible.
We both come from a similar background, and one thing I got to bring up, of course, is configuration control. Is that we have the ability to intelligently design everything from parts, assemblies, sub-assemblies, jigs, fixtures at this point. But every time you make a change, basically, there has to be a mechanism to keep track of those changes, basically, so we can stepwise work our way back and figure out where we came from. It's historically in the ink on paper world that I began with as a young guy. There was a cost to doing that, and there was a time lag effect in doing that. And sometimes, if the customer needed something very, very quickly, you ran with it before that the configuration control system could catch up. And you might be making parts before you actually have revised prints, in the system. So you better remember to catch up, or there's going to be, there'll be trouble at the end of the week or the end of the month. Have we beaten that now? With digital now, have we gotten past that point where we have to worry about the paperwork catching up with the product?
Yeah, I think when we start looking at, you hear all the buzz about platforms, right? Putting all your data in one location. One of the biggest benefits of a unified platform is the ability for everyone to do their piece of the pie, and all the data is just being managed in the back end. And it's not that extra lift that we used to have to do, right? Like, I go draw it on paper, and then I blue line it, and then I put it in a shelf. And then if somebody changes it, then I got to go make the change, then blue line it, put it back on the shelf. Today, it's as simple as the engineer does their part, the manufacturing engineer pulls up and does their fixturing, the robot person picks up their piece, and all of that stuff is controlled and revision managed, because the unified platform where all the data is stored is actually taking care of that. So the engineers just get to do what the engineers need to do, the programmers do what they need to do, and all that data is being handled on the back end. That's really the benefit of this new world we have, where everyone's talking about a platform, is we're trying to reduce the amount of non-valuable effort that an engineer puts in, meaning that we shouldn't be paying a very expensive employee to run around and make sure that they have the right revision, or that the cabinet has the right drawing in it, if you will, if we're talking the old days.
Yeah. Talking about those old days, the manufacturing meetings, we used to call, the blue coats with the white shirts, around that big table. And, I've been on both sides of that table. And if the ability that we didn't have back in the day was the ability to do run what if scenarios. So if we could relax a tolerance on that hole so that we can drill it rather than ream it, so that we can use an automated tapping head instead of having to precision form that thread. All the little things, of course, that have ripple effects down through the system, that had to be negotiated between people like machinists and tool makers or machine operators and design engineers. How much different is the world now if you can simulate that process and simply try it and see how much faster it is to change the way you form a part, for example?
Yeah, I think it's an interesting thing to add on top of, like, when you and I were out doing those things, it was very different because we were often all under the same roof, right? Where today, especially in the last 4 years, most people have spread out. We have organizations spread all over the world. That discussion that we just used to all get in a room and huddle around a table and argue it out no longer really exists in a lot of companies, because I may be designing the fixtures in New York and having a machine in New Mexico, right? So when we start talking about the differences between how it used to be and the way that it is today, it's a matter of using that same platform for everyone to be able to look at and communicate. So we can get on a call or a meeting, and we can pull up all that data, and everyone has the ability to have a say in real time. That's really the benefit of what's changed, because oftentimes today, most companies don't have the luxury just to bring everyone into the same room and hash it out for 3 or 4 hours. And then everyone goes out to their corner of the same factory and then all works together. We're way more spread out, way more dynamic. There are now services that you can just go have parts quoted, and some random person somewhere in a garage is making your part for you. That ability to handle that digital data and communicate effectively is more important than what we've traditionally seen, where we could just all be in the same room.
Yeah. And related to that, I'm seeing a phenomenon now where people that make parts are increasingly expected to help design the component. And we're pushing some of that design function down to people that historically would simply take a rendering, would take a drawing from their customer, and they would say, "Can you make this? How much?" And we'd say, "How many do you need and how fast?" And now it's a situation where there was always a little bit of give and take, where they'd say, "Well, that's too much," and you'd say, "Well, let me look at the design. Could you relax that tolerance? Can you get by without that hole?" And you can negotiate your way to lower costs. But I'm seeing now increasingly a situation where the customer says, "I've got a concept for what I need here. Can you take it from there?" And then basically, so now you've got to get your design platform integrated with your CAM platform, and all that's got to talk maybe with your customer's platform and maybe a subcontractor that you're contracting down the other end. So how much do these things have to talk to each other to actually make money in this business now?
It's very important because the margins are razor thin, right? We don't
Yeah.
have the luxury of padding things anymore for design time and components like that, just because there's so much competition and you have different ways to manufacture now. Maybe I don't have to make it out of, a traditional subtractive process. I can just go have somebody 3D print it somewhere, right? So I think the communication is very key and being able to stay on top of it. And I would also say that part of that switch that's happened also now too is because of the accessibility of all different kinds of modeling tools. It's easy for someone to have that concept, and it could be a napkin sketch, or it could be, hey, I was playing in my garage and I came up with this widget. I modeled it in XYZ CAD. Can you take a look at it and give me some feedback on a better way to manufacture it? I 3D printed it. I know it's going to work, but I need to make 10 million of these things and I want to make them for 10 cents a piece. What's the best manufacturing process? And all the discussion now revolves more around the modeling that happened to be able to validate, like you said, can I program it effectively with a robot? Can I get there? Can I machine it? What type of machine do I have to run? All of those things integrate, and it all starts with that ability to share the same data across multiple groups of people without each person having to remodel, which is what it used to be, right? You give someone a 2D print, they'd model it for engineering, they'd do their piece. Then machining would go take theirs. They would take whatever engineering did, make all the different changes they wanted to make because they had to machine it. And we weren't really talking on the same data. The way that the future is sort of evolving here is everybody has access to that one piece of data and they can all put in their information. And we're just working off one single source of truth versus every department having their own variation of it.
Yeah. The single source of truth, of course, is that's the key element, I think. Today, everything right down to an end mill is something now which has to exist in virtual form as well as a physical form. If you're going to essentially use a modern CAD/CAM system, integrated systems to figure out and simulate how we're going to make something. So in that world, how much pressure does that put on people down the supply chain? It used to be a matter of if you wanted to save money, I could buy my end mill from a cheaper supplier and it would arrive in a cardboard box and by FedEx and away I go. Now it seems to be a matter of, well, it's not enough that you make a physically good product. Your virtual product has to also work. So I can model it in my tool changer, model it in my machine, and then push all that data right up to the design office in the front. So do you think the sea change is going to work up and down the supply chain?
Yeah, 100%. Because if I'm purchasing the tooling, I want to make sure that I'm purchasing the tooling that was spec'd to run that machine. Because I think the other thing that comes into play, if we're being honest, machines move fast now, like scary fast, to where if that mill turn is going to crash, you probably can't react fast enough to hit the e-stop before it crashes, right? If you're running at 100%. So when we look at those things, we need to validate and verify everything is in the position it needs to be, communicate that effectively to the person setting it up so we know all our gauge links and everything are correct. But then most importantly, if I am going to replace that insert or replace that end mill, I want to make sure that purchasing is picking the one that I expect to fit in there. It's a very interesting world we have today where it's not just a half-inch end mill is a half-inch end mill. Right? If I want to make this number, it is that specific half-inch end mill with that specific grind that's going to allow me to do it, or that go drill that I'm going to put in to make it happen. And it's an evolution. Not everyone is there yet. It goes back to what ownership believes in, where they're at in their journey of their career and their life. But it also comes down to educating the people on the floor. And I have an interesting story about that. I'm going to divert here for just a little bit. Bear with me, but there was a company that does these really complex components, and they don't do high volume. They're unique, let's say sets of 4, sets of 8. And they were doing all the validation and simulation. But when I went out to the shop floor, the person with the setup sheet was not educated on what the tooling was. So they would just look at the picture on the setup sheet and then just go grab something out of the crib that looked like the picture. And so maybe a half-inch end mill, maybe a 3/8 inch end mill. And like those pieces of communication are still evolving within a company. But the bigger challenge is when you use disconnected systems, you're leaving yourself open for those types of gaps where someone just says, that looks like the end mill on the piece of paper, I'm just going to go put it in, versus the actual spec. And that's where not having a single source of truth can get you in trouble.
Yeah. We've sort of talked around this a little bit. It's if you're Boeing or you're Lockheed Martin, basically you can apply an almost seemingly an infinite amount of money and personnel and intelligence to a manufacturing problem. But if you're an SME, If you're the smaller shop we're talking about, where you really need to play in the big leagues, and the big league players, your customers, generally speaking, have access to these tools, basically. Do these tools exist in an affordable way that SMEs, that smaller shops, can train themselves up into in a timely way, so they can really integrate properly with these big customers?
Yeah, 100%. And I think that's the difference of where we're at today versus where we were 15, 20 years ago, right? 15 or 20 years ago, it was like Swiss machines and high-end advanced mill turns, and these monster machines were you could only afford them if you were the big companies like you mentioned, right? Today, pretty much anybody can have access to a robot or an advanced machine or a mill turn or a Swiss. They're becoming more commonplace. And along with that, you're also seeing the software that used to only be available for the big companies now available to anyone, because everybody now can play at the same rate. It doesn't matter if I have a phase converter in my garage. I can run a phase converter in my garage on a mill turn, and it will produce parts at the same rate that it would in a big corporate shop. The only thing I have to do is have the software to run it. And I think that's the biggest change we've seen with this evolution. And I think that's also why you're seeing mass customization, because there's so many small companies out there now that, one, can have access to the same software, but also can buy the same machine. And they can now say, I'm going to carve out my niche of the world, do an XYZ ABC, and I'm going to be really good at that thing. Where in the past, you would have to go find a big corporation that decides that's what we're going to do.
Yeah. Now, one characteristic, of course, of the SME world that we've been talking about is that a limited number of individuals have to wear a lot of hats. So if you have the luxury being a design engineer who can throw a problem at a manufacturing engineer who can pass it down to a tool and die maker, basically, and you can sort of specialize enough and stay in your niche, we're expecting people now, both up and down. We're expecting machinists and tool makers to operate in some ways as engineers. We're expecting engineers to understand the way tool and die or a mold maker operates at the same time. Do these platforms, is there a way that this can facilitate that process? Does that kind of like bridge those gaps?
Yeah, and that's really the benefit of a unified platform, is the data is the same. I don't have to worry about import, export, calling my uncle and everybody else along the way to figure out which application does XYZ ABC, right? The benefit is I get a file from a customer, and then I can do my CAD, my simulation, my design, and I'm all working on the same file. And that way, if there's a change or a revision, I can have that revision propagated across all of them. What's generally been the limiting factor for a lot of companies is I have a specialist that knows this product, and a specialist that knows this product, and a specialist that knows this product. And every time I want to work between them, I got to export, import, export, import, export, import. And what happens is we're diluting the data and the information with it every time we import and export. So the benefit of a platform is it's just like apps on your phone, right? Like I can go pull up an app and everything knows what a picture is. The same thing relates to platforms today, where I take that model from a customer, the model I designed, put it into the platform, and then I just pick the app I want to use to solve the problem. And that's really the benefit for small companies, is I can now have everyone putting in their piece of the puzzle without importing and exporting a million times.
Yeah. Now, a common complaint I hear from especially smaller manufacturers is that they say, it's great all my machines aggregate a huge amount of data, it's too much. I don't even have the time to actually figure out what's important and what's not important. So a lot of what may be actionable data kind of gets thrown aside because I need to narrow it down to a data set that I can manage. And the other one is that I've got equipment from 15 different manufacturers on my floor, and I paid Integrator a lot of money to pull it all together, but I've got to get the pick and place robot, to talk to the 5-axis machining center, and to talk to the vibratory feeder, and to talk to the second op or third op machines. And it's damn difficult to get them all to talk to each other in a coherent way that doesn't involve tying me up in getting my machines to communicate rather than actually building parts. Is that an issue which can be overcome by larger platforms?
Yeah, because you can simulate and validate all those, right? Yeah, obviously, it takes the setup and the input, but you paid for the setup and the input. You just paid someone else to be the expert of that. And oftentimes, what we've seen is with integration projects, they're great and they're amazing and they take a lot of burden off. But oftentimes, like when we've went out to companies, like, yeah, we put it in, it's great, and it's solved XYZ, but it's only about 80% as efficient as we would like it to be. But we're so afraid of that technology then we're just going to let it run at 80% because we don't want to mess it up to try to get the 100%, right? And oftentimes it's the software component that they're missing. And one of the benefits of a platform, if you will, is oftentimes in the past, you're landlocked by whoever would drive to your facility to solve those things. Now, when you start talking platforms, if I have the virtual twin of that cell and how it operates, I can go hire talent from anywhere that are experts in those fields to program that cell for me without physically having to be at my facility. And oftentimes when you look at those cells in smaller manufacturing areas or, rural areas, if you will, there's just not the expertise right there that will drive every day. There's expertise. I just generally haven't had access to it. With the idea of a platform, I can now get the best talent for my facility, regardless of where they live.
Yeah. Yeah. So much to talk about, a limited amount of time to talk about it. Last question is, what is the best piece of advice you could give to a manufacturer, SME, midsize or large one, that wants to approach you and say, I need an integrated platform to really make my processes sing? Is there one single best piece of advice you could offer?
Without sounding too harsh, the first thing that I would tell anyone that's looking into a platform or a component is you have to put your ego aside and really look at the data of where you want to go. Oftentimes companies will say, yeah, I want to put in automation. I mean, we have a big trade show coming up here next week, right? And there'll be millions of people that show up there and they're all going to look for automation. And then when they get into it, they're like, yeah, but this is the way we've always done it. We want automation, but in this specific way. When you start looking at this transformation and platforms and automation, you really have to put the ego aside and remember the goal is to be more productive long-term than what I am today. And oftentimes with companies, we see the barrier is their ego of this is how we've always done it prevents them from taking the step they need to be successful long-term. And ultimately, if you don't make the right steps, you probably won't be here long-term, because some startup has an opportunity to start fresh and take your business without you knowing it.
Yeah, great advice. Mike Buckley, 3D experience expert, Dassault Systèmes. Thanks for joining me on Manufacturing the Future.
Yeah, thanks for having me on.
And thank you for watching. See you next time.